Hi, welcome to the next channel. So whenever a student joins and they start taking sessions, I do discuss about operating systems and basics of OS, and more precisely it is in line with Linux kernel, because I would like to also discuss a real example like Linux kernel itself, so that we understand how the kernel is put together, and then from there we can also understand how an architecture of an operating system works, and we can also compare various architectures of different type of OS design. So as a part of that, I do discuss extensive about address memory space, let it be the kernel space or the user space, and what happens things put in kernel space, and what happens in the user space, like your process, or we also call as applications. So how the applications can talk to each other, and stuff like that. So students do often get confused about the address space in the Linux kernel space. They do think kernel modules each time as you add a module, they compare these kernel modules with a typical C code. You have hello world, and you write main and C code. See, every C code you write in user space, which means any simple C code you have done in the college, which is not compiled for kernel, like kernel modules, a typical C code, okay, is nothing but a self-sufficient process. Although we don't use the word process, but actually if you run the C code with an infinite loop, it is going to show as a PID, and it will have its PPID, which means a parent process ID and stuff. So it is just nothing but a process. If you write a very small code, it runs and then it stops, so which means it is a very small process. It just gets active, and then it does whatever it is, it prints on the screen whatever it is, and then it kind of terminates. But what happens is, if you do any kernel module, hope you can find here. See, I am doing some code over here. This code is a stub code I have picked from my own website. Long back I have done some video series on proc interface. You can see there I have done first episode about creating a proc file and reading the contents of that file. The second episode is about writing into the proc file, wherein which we can send data from user space to the kernel space. The third one is about creating a directory, and the other one is about some more examples. So anyway, what is the thing is, I picked this one, the second episode stub code, which is writing a proc file, and I want to create a network interface. Okay, I'm just writing something to sort of prototype as a part of SDN, and there is some discussion even with one of my clients. So I thought, let me just prototype on my end. Okay, it's been a long time I've not I don't have any my own stub code, so I thought, let me do from scratch. Also refer the existing kernel APIs, which means this net device APIs and all, and start all over again fresh. Okay, so I thought to start registering the network devices, I don't want to, typically if you find the LTD book or anywhere, they do in module init. You can come here, you can see there you have this hello init and hello exit, and like I said, see the stub code, which means the source code is actually taken from this episode example source code, whatever I provided, which is this writing a proc file. So you come here and you can see there module init, module exit, and you register this proc file and you give sufficient permissions. In this case I am doing 666, so that we get write access to this proc file. So this is what, but I don't want to register a network driver or any driver in this point. I want to try and experiment. I can register somewhere else. And if you recollect, my last episode is about me ranting about I'm not a big fan, which means actually n-1 episode. Okay, hope you can see there me ranting about writing the kernel code without any kernel modules. So I do had a session with one student. He said maybe it suits you, but it doesn't suit with the industry or something. So people do have their own assumptions, but it is very much plausible. You don't need to start things always with this module. It depends on how you put together. It depends on what type of a developer you are. Suppose if you are working as a kernel programmer, but you are doing only just bug fixing, so most of the times you don't write any new code. Okay, you will be going through the existing code and you will be writing new code. In that case, you never need to write any kernel modules. But if you are creating new code, if you are writing new code, then if it is not just bug fix, then you may add in some place either as a module or without a module through some hack or brute force way like me. Okay. So that way, if you come here, you can see there we are able to create here the proc file, and when you write that file, what happens? When you read that file, what happens? You have this FOPS APIs. You can see there both of them are registered over here as a part of file operations, okay, of that proc file which we created. Okay, so here I have replaced this code with whatever code of mine trying to register the kernel network device. Okay, and you can see there the module exit, it has this for loop. I'm trying to free that resource. So again, this free resource, I don't want to put it here. Eventually I want to put it over somewhere else, okay, or else maybe I can write it that part in the right portion itself, so that I can start sending commands. When I send some command like create interface, it creates a net device interface. I mean, it creates a network interface. When I do delete interface and stuff like that through proc file. Okay, okay. So interactively I can do through proc file, and it should the objective is it should able to do that. Eventually that's the intent, so that I can type some commands through proc interface, or I can even provide a sort of UI, an abstract UI through a web interface or something, or else some type of command line interface either through PHP or C, whatever it is. So that's the kind of objective here. So eventually I may move even this free net device stuff over here, but before that I'm trying to prototype this, and I'm getting some type of error. When I start this, it shows as as killed. Okay, so I'm kind of confused. I did able to find that when I pass any string in the proc, through the proc, it is coming with this new line, the new line entry, which is this /n. So I'm doing this and something, but anyway, I just put this type of stuff. I just hard coded the interface name. Let's just hard code this interface name as test. Okay, so this is what I'm doing, and it somehow is throwing up an error, and it is kind of frustrating, because like I always mention, when you work in kernel stuff, it doesn't matter whether you work in kernel module or you work in kernel other places and compile the entire kernel. If you do some goof up, the whole OS is going to crash, and the only option is most of the times you need to restart the system. Of course you can debug and stuff like that, but if it crashes, there is no other option, you need to restart. So which is why I thought of showing you that if you do some goof up here, see, the whole objective of this video is not to teach you about proc. If you are interested, go through, I may attach this web page link. You can go there and watch this video series, and you can take the code and experiment. Okay, same way the network driver, somewhere I remember discussed that. If I able to find, I can add that link as well. So again, the whole video is not about the exact code inside. The video is about memory space. When you do anything in kernel modules, it is going to happen in the kernel space itself. So the whole kernel space is going to mess if you do anything, any goof up in your kernel modules. Okay, so as you can see here, I just hard coded. The intent is I'm not supposed to do that. Whatever it comes here, I'm supposed to pass it over here. So I can send any name I want, and then it should able to create the dummy virtual network interface. Okay, so that's the intent. Okay, suppose if I go to the proc folder, I should able to do echo say test1, and then I do the file name, okay, whatever it is, let's say sudo, and if I do that, it should able to create a dummy network interface. So once it is done, if I go to this tab and if I do if config, it should show that new interface. Of course, I have not yet done the entire needed stuff. It is still work in progress. So we go back and we revert this to test, and this is the code. I am keeping a sort of array here, as you can see here, array of pointers, so I can create like that somewhere around 20 interfaces, but the objective is to able to create even 1000 interfaces so that we can do some automation with SDN and stuff. So this is just still work in progress. So you can see there, this is what is happening. But if I compile this, let me do a make. If I compile this code, it gets compiled, and then you can see there it gets compiled, and I can do sudo insmod of proc example.ko. It will get inserted as well, okay, without any hiccup, because if any goof up, it is happening over here. So far the module init is fine, okay, so here it is fine, but if I do anything, it happens over there. I need to keep an eye, because once it crashes, it may ruin this screen capture over here. So what I do is I run it, and when I run, I try to take a video from smartphone so that we can still able to get that video feed. Okay, so as you can see, I have done insmod. So let us do a ps, let us do an ls. So you can see there the file should get created. Okay, yeah, it's not yet done. I can do that insmod. Yes, once it's done, you should able to get this file, and this is the file. So what we do is we can just do echo test, and then we can pass this file, and then we can do is sudo, and we should also capture the log messages. So you can see there we can do is tail -f where log kernel logs, and you can see there it is it is all working fine. And now the confusion starts the moment you try to write this proc file, because it is going to invoke that API, okay, right? So it is going to invoke that handler actually over here. So before running this, what we can do is we can stop the video capture, because it is going to crash the system like I mentioned. So let me just stop this video capture, and I can try capturing through the phone. Okay, I can do that. Let me set it to video mode, and let me just capture. Yes, so you can see there I'm about to enter this command, and you can see there it is inserted, and it is so far nothing happened. So the moment I run this, okay, let me enter the password, and so notice here it shows as killed, which means there is a crash, something is not right. Okay, so I need to still debug the code. I understood this is something happening, and I thought let me transfer this code base to the VM. See, anytime this happens, what you can do is you can transfer this to a VM and work on a VM, because it is easy to restart and do anything you want, versus keep fiddling with the real system and I need to do a hard reboot. Okay, so what you can do is see here it shows killed, and here you can see there is a dump of that error, and I need to go through this, and I need to just see that if there is anything prerequisites I need to do with this version of Linux kernel. Okay, and same way if you do here, if you go here and if I type if config, it is going to crash config, not crash, it is going to hang. Okay, you can see there if config -a, it's not going to return anything. Okay, and if I do cancel or control X, nothing happens. The only option left is to get a proper working system is to do a hard reboot. I have tried even a soft shutdown or a reboot, it is not working. So I can try this right? I can try this shutdown. You can see there. So even if I do that, it will not shut down. It is just going to show that status forever. Okay, it's not going to shut down anymore because there is something goofed up in the kernel itself. So things like that, we can debug. And what I meant, what is the objective of this video is, see, whatever variables over here in this global context, see, these are the global variables, right? So over here, right, hope you can see the proc example.c. So whatever variables over here is a part of the main kernel space. Okay, so these are not a part of some address space of this kernel module. Okay, these are very much a part of kernel space. If you do any goof up of any of these variables, or in this case, you can see there, if you notice here, see this net port is nothing but struct net device of net port pointer, right? So the pointer, I'm getting it alloc net div, and I'm checking if it is allocated and do this stuff further of the data structure handler. Okay, so here is where somewhere it got that error. I need to debug that killed is coming right after this or after this, so which I am supposed to debug. Okay, I may do that sometime later. So what is the thing is, as you can see, even this address space is very much a part of kernel itself. So if there is any goof up here, it is going to reflect the entire system because it's all the same address space. So the main intent of this video is, don't get confused when you do anything in kernel modules. Okay, let it be a goof up like this private variables or like this global variables, whatever it is all in the same address space like your full complete kernel. And if you do any mistakes over here, it is going to crash the entire system, and not the vice versa. If you do any mistakes in let me stop this. Yeah, not the vice versa. If you do any mistakes in regular C code written in user space, people get confused when I say written in user space, which I meant is a normal C code you write during college, whatever. So anything you write and you compile with GCC and all. Okay, regular C code when you write, these are nothing but user space processes. And any goof ups you do in user space processes, you are going to get the segmentation fault. Okay, if there is any pointer issue, some sort of bad referencing of pointers, you are going to get a segmentation fault, but you are not going to have an issue of entire system crash. The reason is it is in the logical address space, it is not in the address space of the kernel. Versus a kernel module, let it be a module, still if you do any goof up over here, it is going to crash the entire system. And most of the times, only option to get a proper working system is to do a complete reboot. Sometimes even the reboot will not happen. The only option left is to do a hard reboot or pull the power plug out and then put it back, and then you should get everything back working again. Okay, so hope this clarifies. There is a way, if you want these global variables to be exposed to the other kernel modules or something, it is quite easy. You can just put an extend reference in the header files and then put it in include Linux folder somewhere here and there. Okay, somewhere here and there you can put that. Hope still the system works. Let me check if any pages I can open. It is sort of inconsistent, as you can see here. Yeah, it is working. Let me try screen capture. Yeah, it is working. So usually you can do is you can expose this global variables over here. You can go to include, and any of this folder you can put. Suppose if it is networking, then you can put Linux and net somewhere. You can create any folder if you want, or as it is you can put any header files over here, and any global variables you can expose through here. So you should be able to find some external reference here. So it depends on that header file. So if there is any exposed global variables, you should find over here. Okay, so this way you can expose. It is quite easy. Yeah, you can see there extern int file cap. So if this way the global variable is exposed, all you need to do is in your kernel module, you just need to include this Linux capability.h. So the moment you include here, you should be able to access that exposed global variable. Same way here I have done that. If it is a proper kernel code, if it is a mature kernel code, and if it is pushed in the kernel code itself, Okay, all I'm going to do is the header file I can create for this, and I can copy that header file and include Linux somewhere. And okay, all I need to do is, if anywhere else, if I want the access to this global variable, I'm going to do that header file access. But still, like I said, you do a kernel module or you do without a kernel module, let it be whatever it is. If you write any code, it is all in the same address space. And if you do how we can confirm if it is all in the address space? By this way, if you do any goof up, it is going to kind of make system either inconsistent in this way, which means as you can see, I get a partial working system, or it may completely crash the system as well. So before I conclude, I can also do one thing is I can stop this recording, and then what we do is we can start capturing the screen via the phone, and then I can show is the way it is hanging when I do the shutdown. Okay, see, let me just close everything, and then if I do, see, nothing is on, and then I can just do a shutdown right over here, and then if I do shutdown, it's not going to happen. Okay, let me do this shutdown anyway. So hope you can see it is just going to stay over here. Okay, it is not going to shut down. I have tried a couple of times and I never able to pass through this phase. Okay, so I understood there is something is goofed up, and the only option left for me is to do some kind of hard reboot over here. Okay, either I need to turn it off through the power button, or else I need to use the reset button over here. Hope you can see. So this is the reset and this is the power button. So nothing is going to happen. It is still going to show that. Okay, if I press reset, or I can just power it off. Yeah, and then I need to start once again, and then it will start to boot. So this is what happens. So hope you learned something new, and hope this also clarifies one of the FAQs many do get. Okay, so if you have anything to discuss, be in touch via mail or post your queries, not feedback, in YouTube comments. Okay, thanks a lot for joining this video. Stay tuned. Have a nice day. Bye bye.